Okay folks, today we're going to have a look at differentiating the functions sin x and cos x. So if we start here, you can see that we're actually looking at y is equal to sin x. And we're going to have a look at the gradient function of y is equal to sin x. Well, the first thing to have a look at is to notice that the gradient, as it moves along the curve at each of these peaks and these troughs, is of course we're at a minimum and maximum point, so the gradient is 0. So at each of these points the gradient function will be 0, so we can put those points on straight away. Now if we look at the rest of the gradient function between various bits, let's have a look at what happens when we're at this point here. If we were to draw a straight line, now that's going to be quite tricky for me to do, but let me try. Because we are in radians, and it only works for the fact that we're in radians, the gradient at each of these points is actually equal to 1. If you have a look at the change in y over the change in x, so if it was like going from a half at this point to minus a half, we've got a change in y of 1, and actually we've got a change in x of 1 as well, because we are in radians. So due to the fact that we're in radians, at each of the points where the graph of sin x is equal to 0, the gradient function will in fact be equal to 1. So we can put 1 on there, 1 on there, and 1 on there. Now if we have a look at joining all of that up, let's just see if I can rub this bit out. Okay, so that's what we're looking at with our function, and if we now have a look at each bit that's happening, so if we look between, what would this be? This would be this section here. So if we look at this section as we're going along here between these 2 points and look at the gradient function, we can see that it's positive all the way along here. So it needs to be above the x-axis in our gradient function, but we can see that its maximum point is up here. So that means that our gradient function starts at 0, gets more and more positive, reaches a maximum, and then comes back down to 0. Now if we look at the same idea in this area of the graph, once we've reached our maximum and follow it along, we can see that it's a negative function with its minimum point, if you like, or its maximum negative being at this point here. So that means that it will go down here to -1 and up to 0. So although that this is a 1, this is actually equal to -1 because it's a negative gradient, so it should have been down there like that. Okay? Same thing happens with this one, of course, because it's a negative gradient, it's like that. So it's got a negative gradient of -1, and we can draw it like that, and so on and so forth. So if we have a look at what's happening with our gradient function, we will see we've just developed y is equal to cos x. Now if we do the same thing and we draw y very similar to, so we started with y is equal to cos x, and if we have a look at this function, it looks very similar to y is equal to sin x, but in actual fact you can see that y is equal to sin x would have looked like sort of that, and would have come down to here like that. So in actual fact we are looking at a reflection in the x-axis, so the differential of cos x will in fact be minus sin x, and that's why the differential of cos is minus sin and the differential of sin is minus cos. Now let's have a look at what happens when we do y is equal to tan x. Well, we all know that y is equal to tan x is actually just sin x over cos x. So here we're looking at using the quotient rule, with u being sin x and v being equal to cos x. This new expensive pen's causing me a bit of trouble. Right, so u dash, we've discovered when you differentiate sine, you just get cos. And when you differentiate cos, you just get minus sine x. So now we can apply the quotient rule. So y dashed will be low d high, so that will be low d high, cos squared, minus high d low, which is those two together. So we've got another minus sine squared, so that becomes plus sine squared all over the square of what's below. So that's all over cos squared. But this thing here, of course, is just equal to 1. So we get y dashed is equal to 1 over cos squared x. And as we all know, that's just equal to sec squared x. So to recap, these are your sine, cos and tan functions and their corresponding differentials. These need to go into your notes and be learned for your C3 exam.